Subtract the following two rational expressions. The first one is x plus 4 over 2x plus 10 minus the second one, which is 5 over x squared minus 25. Now recall, when we're combining rational expressions, it's the same way as combining numbers or fractions. So if you have a fraction and then you're subtracting another fraction from it, you want to make sure you have the same common denominators to combine them. So that's a poor example. But in any case, what we need to do is to build a common denominator from the LCD of these two denominators. And the first thing we need to do is factor each of the denominators. So I'm going to rewrite this expression with factor denominators. For the first expression, 2x plus 10, you can factor out a 2. And what's left over is x plus 5, right? Because when you distribute that 2 back into the parentheses, you get 2x plus 5 times 2, which is 10. And then for the second one, the denominator, x squared minus 25, well, you can think of that as x squared minus 5 squared. So that looks like difference of squares, right? Which means that this turns into x plus 5 times x minus 5. So let's write that. Great. So now we have to build the LCD from the factors, and we do this the same way we do it with numbers, right? So in this case, the LCD is all of the factors without repeating any. So 2 times x plus 5. There's already an x plus 5, but there isn't an x minus 5. So the LCD is 2 times x plus 5 times x minus 5. So now, in order to combine these, we have to have the same denominator. And the best way of doing this is to make each of the denominators the LCD. So we want to fill in what's missing from the LCD in each of the denominators. So for the first, there's a 2, which is in the LCD, right? And an x plus 5, which is in the LCD. And what's missing is an x minus 5. So we're going to multiply the denominator by x minus 5 so that we can get the LCD. But remember, since this is an expression, whatever we do to the denominator, we have to also do to the numerator so that we can balance everything out. Right? And then for the second expression, we have, let's use green here, we have an x plus 5, right, up over here, and an x minus 5. So what's missing is this 2. So what we do is we multiply the top and the bottom by 2 this time. So now combining everything, let's just FOIL in this these two products in the numerator. So we get x squared minus 5x plus 4x minus 20 on the top, and then 2 times x plus 5 times x minus 5 in the bottom. There's very little point into multiplying the denominator out at this point. We might do it later. And then for the second one, 5 times 2 is 10 in the numerator, and then in the denominator we get right? And I just I'm using the multiplication, the commutative property of multiplication. That is right, since I had this was x minus 5 times x plus 5 times 2. It's the same thing as 2 times x plus 5 times x minus 5, because it's true that for any numbers a times b times c, it's the same thing as c times b times a, and it's the same thing as b times a times c, and you can go on, right? That's the idea of commutativity. So now we have that these two denominators, they're the same. So we can use the addition property of fractions, which works the same for rational expressions. That is, when you have a fraction and you're subtracting another fraction from it and the denominators are the same, the result is just the difference of the numerators over that common denominator. So let's do that. So let's combine the numerators. So we get x squared minus 5x plus 4x is just going to give us minus x minus 20 and then minus 10, which is the second numerator, all over that common denominator. Okay, then simplifying further, we get x squared minus x minus 30, looks like, oops, all over 2x plus 5 times x minus 5. And now in the numerator we have a quadratic equation, and by now you should just be itching to try to factor it, because that's what we do when we have a quadratic equation, right? So factoring the numerator, I believe the factors are x minus 6 and x plus 5, right? And if you're never sure, you could always check by foiling it back in. You get x squared minus 6x plus 5x minus 30, which, yeah, it's x squared minus x minus 30. So that's the numerator, and the denominator stays the same. And now notice there's an x plus 5 in the numerator and an x plus 5 in the denominator, which can be factored out and canceled. So what's left over is x minus 6 over 2 times x minus 5. And since there's nothing else that we can do to reduce this rational expression, then this is our final answer.